Hello everyone, my name is Long Siyu, a student from USTC. My presentation title is A Study on the Effect of Composition Training on Functional Gradients. Music is a universal human activity involving perceptually discrete elements organized into hierarchically structured sequences. Music training can change the function and structure of the human brain, and when the elder non-musicians respond to the fast-changing speech elements, they will have neural timing delays, which will cause older adults to experience difficulty understanding speech. These age-related declines are not inevitable. However, older adults with a lifetime of music training do not exhibit neural timing delays. Music can also change the structure of a human's brain. After 2 years music training, children showed a different rate of cortical thickness maturation between the right and the left posterior superior temporal gyrus and higher Fa in the corpus callosum, specifically in the crossing pathways connecting superior frontal, sensory, and motor segments. Despite substantial research on cerebral function in musicians, there is a need to establish a neurological framework to better understand the functional hierarchical structure of the cerebrum. Thus, we evaluated the functional hierarchical structure in musicians, adopting a resting state functional collectivity-based gradient approach. As for methods, 20 non-musicians and musicians were selected in our experiments. Specifically, all the musicians are composers, and we used the MATLAB Toolbox brain space to calculate the functional gradients of them. We compute the rest state functional MRI functional collectivity and use it to compute a cosine similarity matrix. Then the diffusion embedding was applied to create the first gradients on the cortical surface. Finally, we calculated the two-sample t-test of gradients in musicians and non-musicians. And we also calculated the correlation of gradients and the composing training data. Okay, let's go to results. As you can see, figure A shows that the principal gradients of musicians were larger than that of the non-musicians in right sinus gyrus, while lower in both sides of orbital frontal and left middle frontal gyrus. And figure B illustrated that there is a negative correlation between gradients of the left orbital frontal cortex and the training duration. Meanwhile, there is a positive correlation between gradients of right orbital frontal cortex and the composition scores, and all the results were FDR corrected. Our study has found that the principal gradients of orbital frontal cortex in musicians were lower than that of the non-musicians, and the music training duration and composition ability are both correlated with gradients of orbital frontal cortex in musicians. And this study may improve our understanding of the neurobiological mechanisms underlying music training. Okay, that's all of my overall presentation. Thank you.